Hello, everyone. Let's talk about how to solve quadratic equations in a second way. And this second way is called by square roots. All right, so solving quadratic equations by square roots. Okay, so when do we use this strategy? Well, we use it whenever you don't see a visible bx term. All right, so that's all I'm going to say about that. If you have an ax, if you see ax squared and c, for example, but no bx term, then you are good to go with square root method. All right, in other words, we're looking for something that's not really in standard form. All right, when you don't have standard form, you have this possibility of using the square root method. All right, but let me show you what I mean by this. All right, so you can see, for example, in this first example, the structure looks quite different. It does not appear to be in standard form. All right, it's like this cross between standard and factored. This actually leans more towards vertex form, which is a Math 2 topic. But don't get distracted by that. Let's see how this works out. So if I have the problem 5 times x minus 1 squared minus 39 equals negative 19. I'm going to solve this using, and I know I called it the square root, solving by square roots, but really we're going to solve this by inverse operations. All right, I'll just call it ops. Inverse operations, just like we did with linear equations. So I'll start by adding 39 to both sides. Right, I'm going to add 39 to both sides, and I am going to, when I do that, I get 20 on the right side. Now I've got 5 times x minus 1 squared equals 20. So because this is multiplying by 5, I can divide both sides by 5. All right, which gets me to x minus 1 quantity squared equals 4. All right, now rather than multiplying this out by FOIL or with a box, what I'm going to do instead is I'm going to take the square root of both sides. So now that I've arrived here, I'm going to take the square root of both sides. Okay, it's not showing me anymore. Take the square root of both sides, and what you need to make sure of is that you take a positive and negative square root. All right, so we're going to say x minus 1 is equal to 2, but we're also going to say x minus 1 is equal to negative 2. All right, when you solve both of those equations, you get x equals 3 and x equals negative 1. All right, that is how you solve through the square root method. Okay, and let's look at a second example. Another way to describe when to use the square root method, if you only see one x, if you only see one x, then you have a high probability that you can solve this with inverse operations, square roots. All right, so I am going to do the same thing in this problem. It's just a little more complex, but it's really the same things going on right here. All right, so I've got 16 times 4x minus 1 quantity squared minus 46 equals 35. What I'm going to start doing is I am going to use the inverse of minus 46. I'm going to add 46 to both sides. Okay, that gives me 81 on the right side. I will proceed by dividing by 16. So I've got 81 sixteenths. Then I will take the positive and negative square root of both sides. So that gives me 4x minus 1 equals 9 fourths, because I take the square root of 81 and the square root of 16. So 4x minus 1 equals 9 fourths. And then also, you can hardly see that down there, but that's 4x minus 1 equals negative 9 fourths. Now that gets a little hairy with the fractions, all right, which you can use a calculator with your fractions, right? But it really ends up at 4x equals 1 plus 9 fourths. I can turn my 1 to 4 over 4, right? Meaning 4 plus 9 is 13. So 4x equals 13 fourths. And then divide both sides by 4, which will give me 13 sixteenths. All right. And your other answer, I believe you end up with negative, let's see what that is, negative 5 sixteenths. Okay. That is how you do those problems.